Hello, everyone, and welcome to a special edition of the Broadband Universe podcast series. This, the first of three conversations with members of the Hexatronic U.S. team as we explore multiple aspects of micro-cabling systems. And it's a pleasure to welcome my guest today, Beni Blell, the head of sales and marketing for Hexatronic U.S. 30 years of experience in optical fiber passive systems, including pioneering work on early fiber to the home systems. And Beni, welcome to the Broadband Universe.
Craig, thank you so much. What a great opportunity and what a wonderful time in this market. Fiber is finally coming to our homes. Our communities are being enhanced. Life is getting better with better communication. It's a good time to be in the fiber business.
No doubt about it. Sort of a golden age, if you will. And it's exciting for me today as we begin learning about sort of the state-of-the-art air-blown fiber technology, as well as the Hexatronic story. So to get that conversation started, give us the background.
Briefly about Hexatronic, we are a global company. Just crossed the 1,700 employee threshold, roughly $650 million in sales, and a market cap of about $2.5 billion. Our largest market is the U.S., and we have been growing very rapidly over the last few years through both organic growth as well as through acquisition. Just again, briefly, for those of you who have never heard of Hexatronic, our roots go back to Ericsson in Sweden. Hexatronic acquired all the global assets from Ericsson Cabling Systems back in the 2013-2014 timeframe, and we've been growing rapidly ever since. Specific to the U.S., acquisition in 2018, Blue Diamond Industries allowed us to enter the duct and conduit market in the U.S., transfer of microcabling technology, and we now have recently opened our third factory in the U.S. here in Clinton, South Carolina. So growth is good, and we are providing the components that go into fiber to the home systems.
And when you look at that kind of growth, Beni, that is phenomenal, given the length of time that we're talking about. That has to be exciting for you and the company as a whole when you look at the opportunities that are at hand.
It is. I've got personally vested in this industry, as you mentioned, 30 years. Worked for some other companies in this business, and for me to see fiber being deployed at the rate has been warming to my heart, so to speak. One of the things that's actually quite unique with the amount of funds that have become available is, if we look at the way fiber is being deployed in the U.S. in access networks, there's a lot of traditional type infrastructure. And when I say traditional type infrastructure, I mean we've been building networks the same way we've been building them for the most part for the last 20 years. And so where new technology has had some challenges being adopted because of the rate of deployment, there is still immense opportunity to reduce cost of your system, increase the scalability and reliability of your system, the speed to get your components into the ground and light up subscribers, while at the same time building a network that takes sustainability and low carbon footprint into account. So all of these can be addressed with an air-blown fiber system.
Absolutely. Well, I cannot wait. Give us the overview on what we're talking about with the microcable technology.
Certainly. So in the U.S., microcabling systems have been adopted primarily in the feeder part of the network, and that is from a central office out to a point of presence, and even in some distribution networks. And when we talk about air-blown fiber today, we're typically referring to larger type microducts in millimeters. For example, I think I'm holding up a 1410 multi-duct here, and you would blow a microcable, anywhere from 24 fibers up to 864 fibers that Hexatronic offers. And these would typically go in the, again, feeder or trunking system, and rarely are they used in the distribution and almost never in the drop until the Hexatronic air-blown fiber system is being deployed around the world, and especially in the U.S. today. And when we talk about microcabling in the distribution and drop portion of the network, we are actually talking about significantly smaller microducts. These are 7 millimeter microducts, so 7 millimeter in the outer diameter and 3.5 millimeter in the inner diameter. And through those, you will blow a micro bundle. So this little tiny thing here is 2 fibers, basically 1.1 millimeters, and up to 24 fibers in a 1.6 millimeter unit that you can blow up to 1 kilometer in distance at 100 meters a minute. So 3,300 feet through 990-degree bends at 330 feet per minute. So when we talk about these types of networks, they bring so much in terms of lowering cost by as much as 20, sometimes even 30% lower capex and opex. By being able to blow and utilize those 7 millimeter tubes from a 2 fiber to a 24 fiber, you're actually inherently building significant scalability and flexibility into a network that you typically wouldn't be able to do with traditional type architecture.
Beni, that's staggering. That's staggering.
It is, and there's several white papers that can be downloaded from our website that explain in painful detail where those cost elements are achieved. Materials is probably somewhere in the 30% or plus in terms of materials per home passed, but also labor by being able to blow these fibers long distances through small ducts by eliminating the MSTs, multi-service terminals, or in some architectures, fiber optic closures in an index type architecture. All the handholds that those type of MSTs and closures would go into are eliminated, as is the fusion splicing that those type of systems require. So significant drop in labor, and as I said, our calculations and also being validated by our customers is in the 20 to 30% range. So all very true and achievable.
Obviously, so many innovations in microcabling infrastructure. I'm curious what has changed from air-blown fiber in the past to microcable and microducts. It obviously would be considered transformational technology versus what has been the legacy approach.
Correct. That's a great question. I get asked a lot, why isn't everybody using this, right? So the main reason is, old habits are hard to die. Change is difficult. When these systems first came about, 20 plus years ago, the tubes were smaller. They required more robust handling, so to speak, and they were considered maybe more of a delicate type system. That's changed tremendously with the development of thick wall ducts, which are extremely robust. You're basically building a pathway to each home that is resilient and robust enough to handle all the elements of issues surrounding installation, as well as the longevity of the architecture out there in the underground environment. These are also available in aerial type solutions as well, by the way. So the tools, the workmanship, the training, Hexatronic offers in-depth training on how to design these systems, and even training the contractor base on how to install these systems properly. So we have a full engineering group that does that kind of training and site technology to support our customers as they embark on their deployments of their networks.
Interesting. Well, let's pursue that a little bit more. I'm curious from the standpoint of the layout. When we look at the network architecture of both microcable and traditional fiber, fiber optic cabling, talk about the comparison there.
Well, when you look at the way these systems are designed today, when I say fiber to the home in the underground environment, you have typically high fiber count cables that are built into both the trunk or feeder part of the network as well as distribution, because you really don't know what future applications you will need to be able to provide for, such as 5G microcells or devices that monitor autonomous vehicles, or new and improved and enhanced security devices and sensors. All of these could require a variety of fiber counts at unknown locations. So by building your ultimate network of pathways, you can actually reach those devices at any point in the future as a potential subscriber with up from 2 fibers to 24 fibers today, and rapidly connect those devices or subscribers at any point in time with a few handheld tools and training. So you ultimately do not need to plan and put that CapEx in the ground day one with very high fiber count. You can basically put the plastic pipes in the ground and blow the fiber when you need them. So you're deferring that CapEx. And if you look at fiber to the home and some of the emerging carriers that are overbuilding brownfield type scenarios across the U.S., the initial take rates or subscriber take rates are somewhere in the 15-20% range, and the objective is to grow that subscriber base to 50, 60, 70% over the next 5-6 years. If you build a traditional type of network, you have to put the entire infrastructure, except for the drop portion of the network, in the ground day one. That includes MSTs, the handholds those MSTs go into, and the high fiber count cables to support those MSTs, by not knowing which subscriber is going to sign up for service and when. So with the Hexatronic air-blown fiber system, the pathways allow you to basically pass homes with no fiber in the ground day one in the distribution part of the network. When a subscriber asks for service, a network interface device or NID is placed on the side of the home. A small drop duct is run, and this is a drop duct, would run to the home, and a fiber would be blown either from the home to the fiber distribution hub or from the hub back to the house. A connector is terminated on the end of the fiber, and you are good to go in basically minutes.
So what you're saying, and let me just jump in there really quick, if I understand you correctly, what you're saying is that provides a huge difference in flexibility of the time, the expense, the scale of the network from day one that has to be put in the ground versus what has been the approach heretofore. Am I right with that?
Absolutely, absolutely. So it's a pay-as-you-go model, right? So you're deferring that CapEx and spending that money only when you have a paying subscriber to start getting you that return on investment. So all our customers have validated this solution in terms of the lowered cost, in terms of the speed to add subscribers, in terms of utilizing the scalability that is inherent to this type of architecture. And at the same time, they are being very conscientious in terms of the sustainability part of this solution, meaning you are basically putting less than half the amount of plastic in the ground, which we all know plastic consumes a lot of energy to both produce, but also transport that plastic. So by using micro cabling systems, you're transporting 4 or fewer trucks. So basically 25% of the trucks are transporting these ducts from factory to site, and those trucks are generating 4 times less carbon dioxide and generating 4 times less traffic in your municipality. So all of these are inherent benefits of utilizing a micro cabling type system.
So what you're saying is that there is very much a trickle-down effect in many different directions when we look at being able to decrease the sheer quantity to begin with of what is required to get a network established and operations underway that pay off tenfold or more going forward.
Day one, our math says anywhere from 20 to 30% less CapEx spent, which is pretty substantial. Many of our customers are in a land race, for lack of a better description. The tier one telecoms are spending a lot of money. There's a lot of federal funds that are being deployed into this space. Our customers that utilize our system are able to get past more customers at a much faster rate and light up subscribers at a much faster rate than their competitors. At the same time, they do bring a message of less plastic, fewer trucks, less pollution to the municipalities that they serve. So we are able to empower some of our customers to actually win in the market today in many ways, and win not just for themselves, but the community and for the environment.
Well, and would it be correct then to assume that what you just shared means that a provider in an overbuild situation puts themselves in the position of being competitive drastically faster than in a traditional network installation situation?
Correct. Again, drilling for placement of duct in the ground, it's the same speed whether you're putting a 1.5-inch duct or a multi-duct, that is got 24 little tubes in it. The time and speed comes from the fact that you're not digging pits to put handholds in, to put your MSTs in or your splice closures, and then fusion splicing all those devices. That's what slows you down, which does not slow down an air-blown fiber system at all.
Absolutely. When we talk about this topic, there is so much to get into. Obviously, much more than we can cover in one episode here today. When we look at being able to tell the rest of the story, I know we've scheduled a couple of more visits. Give us a quick preview of what we'll be covering in the second and third installments of these conversations.
We have great people on our team. That's something we're the most proud of. Is Brad Turney is going to be up next. He'll actually run your audience through a case study and provide an actual deployment, which is here in North Carolina, not far from where I'm located. A real-life deployment that one of our customers was able to utilize to actually validate the model. And we'll go through what a design looks like, we'll go through what the bill of materials looks like, and then we'll walk you through both the material and the labor portion of what it takes to achieve a certain number of homes passed, but also what it takes to actually sign up a subscriber. So we'll walk you through that model. And then Roger Vaughn, our VP of Engineering, will go through an MDU type solution. These types of air-blown fiber systems are not only bring tremendous value to your single-family home, brownfield or greenfield, but also the same value applies to multi-dwelling units. And Roger will walk you through the available technologies to get into different types of apartment buildings. We all know that no two apartment buildings are the same, given the time frame and geography where they're built. There's many different ways of getting into those buildings, which Roger will cover.
It's very exciting. Very exciting. And I know that, personally, it is so interesting to be able to get a window into this part of the industry that is making such a huge impact for so many people across the board. And I know for you professionally, it has to be rewarding, given your background and what you've seen develop over the years, to be a part of this transformational effort. Your closing thoughts. I'm
so thrilled to be part of this industry today relative to where it was not that long ago. Fiber is near and dear to my heart, and it is wonderful to see the impact to communities. When COVID hit, it was devastating to see our children, in less fortunate communities having to go to parking lots of McDonald's or Walmart to do their homework. In the greatest nation on earth, as we like to describe ourselves, that's embarrassing, to be blunt. And we are way past due bringing these types of services to our communities and to our kids and to the future of our nation. It's a worthy investment, way past due.
Absolutely, and that's the way we will leave it with you. On behalf of Beni, thanks for letting us be a part of your day. We'll see you next time right here on the Broadband Universe. So long, everyone.
Thank you.